Sam, we've got about like 17 people.
Okay, well, I'm happy to
Yeah.
follow your lead. You're the boss, so if you'd like to start, we can, or if you'd like to wait another 5 minutes, we can do that.
Okay, maybe let's just wait like 3 minutes. We can start
Okay,
at
three. That sounds
12:35.
like a
Yeah.
good number. Some people will be persuading Zoom to open or persuading their Wi-Fi to work.
Yeah.
We're up to 21. Shafali, are you going to stay around at the end so I can even bring you into the conversation?
Oh yeah, definitely. I'm gonna stay for the whole thing.
Excellent.
Okay, I think we can start. Anyways, this is being streamed to YouTube, so if anyone's missed anything at the start, they can just go back and watch it.
Okay, I've been blocked once again from showing my video.
That's really strange.
No worries. I have to be sure to edit all this bit out from the YouTube.
Yeah. Because I did a test run of this before, and the video for all the panelists work, which is why I'm really
So, I mean, mine worked briefly 2 minutes ago, didn't it?
Yeah.
Both on screen. So.
Okay, what I might do is make you the host.
I think that worked a minute ago, didn't it?
Yeah, I'm just worried that the live stream might stop, but
it's not the end of the world. We have a version of this recorded on YouTube.
Yeah, this will be recorded.
Yeah.
Okay.
Okay, that seems to have worked. And the little live stream icon is still there.
Lovely.
Good.
Okay.
Okay. Should we begin?
Yeah.
Excellent. Okay, so good afternoon. My name is Dr. Sam Cooper, and I'm a senior lecturer at the Dyson School of Design Engineering at Imperial College London. And this is our school's admissions talk. So hopefully you've come to join us today to understand a bit more about what it would be like to come and study design engineering. So a little bit about me. I am a researcher in materials design and energy science. So I kind of spend a lot of my time thinking about what goes on inside batteries and fuel cells. I'm also the course leader for the first year engineering mathematics course. So if you came and joined us, you'd be spending a lot of time with me in your first year. And I'm also the admissions tutor for the department. So it's my job to work out which of the roughly 600 applicants that we expect to receive each year shall come and join us in the 90-strong steady state cohort. So here's a beautiful picture of London on a sunny day, which I think should be not too much unlike today. And this yellow band is the bound around Imperial College campus. Everything inside the yellow is part of Imperial, whether that's a halls or a beautiful piece like the Queen's Tower or our departments. And this little bit in blue flashing is the Dyson School of Design Engineering. It's the Dyson building. So here it is, again, a bit of a close-up here. And just to its left, you can see the Science Museum, which I suspect that many of you will have either visited or been aware of. And the road to the right is leading onto the Imperial College campus. Our building used to be the meteorological office and the post office, and it was brought into the Imperial College fold about 5 years ago, and it's been thoroughly renovated. So I'll give you a bit of an experience of what it's like inside the building. So we've got a beautiful cafe, Fusions 54, where our students spend a lot of time interacting, a big breakout space where our students spend a lot of time doing their courseworks or even things beyond the course, like working on their clubs and societies activities together. A beautiful old library, which we've kept, as you can see, with many of its original fixtures and fittings, but we also use as a teaching space, and a boardroom where we can have project meetings or run vivas. And then the basement is a research laboratory. So whether that's 3D printing, robotics, Internet of Things, we've got a very wide range of activities going on down there. And that's mainly occupied by our PhD students and postdoctoral researchers. We also have lots of maker spaces, so studio and workshop spaces. And that's, of course, because our students spend a huge amount of their time making things, so bringing their ideas to life, whether that's in conventional workshops, which we just had refurbished and had a whole new floor put on, giving us about 50% more space, where we've got mills and lathes and laser cutters, or places with 3D printers and electronics equipment. There is a wide range of spaces available to you if you come and join us. So what is design engineering? The question at the core of what we're doing. And we come to think of it as the sort of fusion of design thinking and engineering thinking and practice, but we try to do that always in the context of innovation and enterprise. And of course, you can't really do any of those things unless you have the scientific and mathematical skills in place to really make those ideas robust. So to give you some ideas about what that could result in or what kind of projects that we'll be doing in the department, that could be everything from, adaptive prosthetics. You can see this guy on the left, he's got a training prosthetic that allows him to learn how to do something by direct interaction with the muscles and tracking of his body. Sustainable habitats, disaster robotics, smart clothing, educational children's games, a very wide range of activities, but at their core, they all involve interactions with people, so knowing how people interact with products, and technical engineering skills. We offer 4 taught experiences, and I suspect the one that you'll be interested in today is our 4-year MEng, the Design Engineering MEng, our undergraduate course. But we also have 2 master's courses joint with the Royal College of Art, Innovation Design Engineering and Global Innovation Design. And lastly, of course, we have a complement of about 50 PhD students who are partially taught, I suppose, and they work with people like myself, the lecturers, in order to do the cutting edge research that we are pursuing in the Dyson School. So one of the key things I want you to take away from today is that design engineering doesn't just focus on artifacts or things. We also think about the problem of design more broadly, in terms of systems, services, experiences. Okay, so that means a much wider range of activities than just the material, perhaps mechanical world. And to pursue that, you need to have a very broad understanding across a wide range of disciplines, not just including technical function, but also aesthetic functions, social, economic, psychological, latent, and emergent, a very wide range of perspectives when you come to apply your skills to resolve a particular problem. So I will briefly lay out the actual contents of the degree so that you can understand how we build you up with those skills. And the first 2 years, we build the foundations, and the second 2 years, years 3 and 4, we give you a bit more freedom so that you can go and explore the areas that you are more personally invested in. So there's kind of two parallel threads, the more design aspects and the more engineering aspects in the first 2 years. And then we try and meld those together as much as possible in years 3 and 4 to make sure that you are a sort of rounded design engineer. So of course, we've got the classic introduction to maths and computing and electronics early on, solid mechanics, products and materials. But you've also got one of your major modules, the human-centered design engineering, flowing with you all the way through the first year. And here is some examples of the kind of assessments that we run in the school, where actually about 80% of all of the marks available in the degree are from coursework rather than from conventional pen and paper exams. And we believe that this gives you a much more authentic experience of being a professional engineer and is a much more authentic way of assessing your ability. So here is the exam from Electronics 1, where students have to design a robot that can go and extract information from a landscape, whether that's some ultrasonic or infrared or mechanical information from the world around it, and retrieve it and bring it back to base. And here is actually an example from Electronics 2, I think, where the students have to design a balancing, dancing, two-wheeled Segway robot. And so throughout the course, the students are learning about each of the components on the circuit board that you can see there. And then the final assessment is to demonstrate that it has the properties that were required of you originally. So it can balance on its two wheels, be controlled, and dance to music. So year 2, you increase your sort of design skills by thinking about sustainability and industrial design. And again, you've got more foundational areas in terms of technical skills, data science, solid mechanics, thermofluids. And Gizmo is a lovely module where you actually begin to put your electronics and solid design skills into practice with a coursework only module to think about actually designing something that is not just technically correct, but solves an interesting design problem that you get to specify. Throughout the degree, we ask you to literally stand behind your work. So you won't just submit your work to a marker to be reviewed, but on many occasions, you'll also be asked to stand behind your work at a show, and we'll invite in industry and academic experts to come and review your work and talk to you about it and ask you to justify the design decisions that you have made. In your third year, we have the first opportunity for you to select modules of your own free will. So 2 different elective type modules. And we also have some of our capstone modules, optimization and robotics, which really bring together all of the technical skills you've learned so far. And Design Engineering Futures is the first time that you have a major group coursework. So you'll be working in a group of 4 or 5 students for 2 whole terms. That's several months of work together. And you'll use that time to really not just, again, not just solve a problem, but spend a lot of time thinking about whether you are asking the right questions. And in particular, in this futures work, exploring key trends in society and in technology, and trying to understand where those trends might lead in the future and how you might pull together a design innovation and intervention to come and affect the future processes in a positive way. At the end of your second term, you will be going off on an industrial placement, and we will give you some assistance in finding that placement, but ultimately it falls to you to find something that you think you're going to be passionate about and derive value from. And you'll spend 6 months with an industry partner. I'll come back and talk about that in a second. Some insight into the elective modules. Here's a short list of some of the modules currently available. Actually, this list has already doubled in size since I prepared these slides. And we now have also electives in machine learning, the sharing economy, and ethical design. And here is an example of the deliverables from one of those electives. Here is audio experience and design. And you've got a student in the top 2 images there who has made a sort of physical representation of the human inner ear, so the cochlea. And this object uses light to represent where different frequencies of sound interact with the ear, giving you some insight into how hearing actually works in humans. And of course, as you can see, to bring that to life, this student has had to use their coding skills, their electronic skills, their prototyping skills, their manufacturing skills, and their new understanding of the audio system in order to pull all the pieces together. The school also has a particular focus on robotics and has many different robots sitting or living in the basement, I suppose, including Robot De Niro on the left, who is sort of one of the candidates touted to be a key enabler for the next generation of robotics, where it's a somewhat generic platform that can be taught to undertake a very wide variety of tasks. And this has allowed people to mass produce the same type of robot and deploy it in a very wide variety of industrial scenarios. One of the other key attributes of De Niro is that you can train it with your hands. So actually, the money spent on robots in an industrial setting is a lot, but the money spent on software engineers to train the robots far outweighs that. And so De Niro seeks to solve that problem by having people who can already do the task, grab it literally by the hands, show it how to do the task once. De Niro will learn that and be able to do that again repeatedly forever. So this list here gives you some insight into the types of companies that our students have gone off to for their industrial placement for 6 months. And I'm sure you're aware of many of the companies on that list. This list is already a year out of date now, and we have a very wide network of connections based on where students have gone to work after the degree or where students have gone to work for their 6 months placement. And in my experience as a tutor on the course, the companies are, without exception, delighted by our students and the skills that they bring to the companies that they are placed at. So in your final year, you come back from your 6-month placement, and you only have 2 compulsory modules. So enterprise rollout, where you try and understand how to convert your ideas into products and companies, and your master's project, which is a project throughout the whole of your 4th year, where you work paired up with one particular academic, and you will propose projects to them and they will propose projects to the student, and you will find good pairings that allow both of them to explore their interests. And then the final aspect of the 4th year is that you get to select 4 elective modules. So 4 modules of your choice. So perhaps coming back from your placement, you've decided that you're actually really fascinated by biotechnology. So you can go off and do modules in the bioengineering department, or perhaps you're particularly interested in business and want to know more about entrepreneurship, and you can do modules with the business school. So there's a very wide range of activities you can do with those elective modules. And so what I'd like to give you now is some quick insights into 2 of the projects, the master's projects that I've supervised in previous years. This is Hypnos, and it is a device to understand and hopefully promote high quality sleep. So the student, Francois, first explored what are all the things that you can measure about sleep, such as the light, the temperature, the humidity in the room, the amount of sound, and what are all the things that you can affect? Well, of course, there's a lot of overlap there. You can modify the temperature in the room. You can modify the amount of light in the room. But you can also measure things about the sleeping person. So you can monitor their movement and their heartbeat. So he went and explored some prototyping to try and see what would be possible, the time frame and the cost limits set for him. And you can see here he's developed a little circuit board to do some measurements in the room. And this is, of course, based purely off the skills that he's learned during his time in the design engineering undergrad. So he's then been able to take some measurements, I think, from himself in this case, and then used some machine learning algorithms to try and extract some patterns to give him insight into how the user might improve their sleep on the following night based on their behaviors in the day. So have they gone to bed at the right time? Have they turned the lights on low early enough? Another project here from one of our students, Leah, where she's first explored the concept of water scarcity. So different places in the world have severely different access to fresh water, drinking water. She's then found an interesting material, and this is a polymer, a plastic that is able to absorb water from the air at one temperature and reject that water back, perhaps into a bucket at another temperature, allowing you to pull drinking water from the air. She designed a test rig that would enable her to explore the sort of performance metrics of this material, and then also perform some sort of ideation. So if you were able to scale this material, if you were able to reduce the costs, if you were able to pick a particular case study, a particular environment, what do you think this product would look like? How would you go about bringing it into the state of a product? And I also just wanted to share one of these third-year group projects that I mentioned, the Engineering Futures project. And this is one of my groups from last year who explored the concept of democracy and how machine learning and some of the scary video and image manipulation tools might significantly impact the quality or the power of democracy or democratic actors within nations. And so if any of that looks like it might be exciting to you and you'd like to come and join us next year, here's what you need to do. So if you're taking the A-levels, you need to do at least 3. And you also must get an A star in mathematics. And then we're very likely to ask you for at least either 2 A's or an A star and an A in addition to that. And we don't mind which other subjects you take beyond mathematics. We don't insist on physics. If you're taking the IB or any other international qualification, we have details on our website about what grades you'd need to do in that case. So you will also need to write a personal statement because you'll be applying through UCAS. So you'll need a personal statement and a reference. And the thing to stress is that your personal statement shouldn't just be a sort of poetic description of your passions, but what we're looking for is a real, perhaps set of evidence to show that you have put in work to learn new skills, to enter competitions, to set up and run societies, to actually use your skills in real world, rather than just telling me that you love the concept. We interview about 300 candidates a year, and then we make about 160 offers, and then we welcome about 90 students each October. And this year's process has just come to a close. So we've finished doing all of our interviews this year, and this week we'll finish making all of our offers. So currently our course is about 45% female, and it comes from all over the world. So about 60% from the UK, 15 from the EU, and 25 from overseas. And as I mentioned, about 600 applicants, about 300 interviews, about 170 offers, and about 90 students arriving each year. So our graduates will receive a master's level qualification, just like any other engineering degree at Imperial, an MEng. And we've also, as a department, been accredited by various key institutions, such as the Institution of Engineering Designers, Institution of Mechanical Engineers, and Institution of Engineering and Technology. And the key idea is that our degree has been specially designed in collaboration with industry and with these institutions to meet the needs of modern engineering companies, who in particular highlighted that some engineering degrees are perhaps overly focused on the purely theoretical aspects and don't give students enough time to really make use of their skills, practice them, and bring products and concepts to life. So hopefully our degree will give you the sort of creativity, enterprise skills, and industrial experience necessary to give you a really good start in your career. And students from our courses have gone off to work for a wide range of top companies that you'll be aware of. And we will, we're a relatively new degree, so we've only been around for 5 years, but we'll be increasingly making sure that people in our network come back and tell the students the secrets of how to get jobs at the fantastic companies that they've gone to work for. So a few examples of things that have spun out of the courses at Imperial. This is Qbot, a little robot that goes underneath the floor in your house instead of a human being, and can spray insulating foam underneath your floor to make your house more energy efficient. This is one of my favorites, Petit Pli. It is a clothing brand for little kids. The fashion industry is one of the biggest sources of pollution in the world. And of course, little kids are particularly bad actors in that regard, as they grow out of their clothes so quickly. So these are clothes that stretch as the kids grow, and meaning that you can use them for much longer. And then Bare Conductive here is an ink that conducts electricity. So you can, on the one hand, use it for educational purposes, just to draw circuits very easily on paper and understand how electricity and electrical circuits work. But you can also create desirable products. So, for example, packaging systems where the box, when the box opens, it knows that it's open because it's got a little ink circuit inside it that you've perhaps broken by opening the box, and it could allow a light to turn on inside the box, giving you a particular experience. This is Yosai. It is a digital avatar, and it's a project exploring your interaction as a user with the digital world. And the key idea is here that we now have a variety of digital experiences, whether that's on your phone or on your work desktop or your home desktop, but also in the real world. As we increasingly make use of virtual and augmented reality, you're perhaps going to want a common thread linking all of your digital experiences together. And Yosai is an avatar that will come with you into any of those spaces, giving you a sense of consistency and empowering you to use your devices in a way that always feels familiar. So with that, I'd be delighted to answer any of your questions. And I, as the admissions tutor in particular, would be really pleased to see you all apply for the school next year. Thank you very much.
Thanks, Sam. Just a note about the questions. You can ask anything that you want in the Q&A tab that's below. And Sam, since you're the host, you have the power to allow people to talk. So if anybody wants to speak their question instead of typing it out, just raise your hand and Sam will be able to let you turn on your mic.
Wow. Okay.
Yeah.
Well, Fred has asked, when do applications open? So we follow the standard UCAS cycle. So I think the UCAS applications process opens in sort of September-ish. But more importantly, it closes towards the beginning of the year. So I think it's February that it closes. So this year's cycle has been complete. But yeah, applications for next year, I think you can submit around September time. What is the balance between design and engineering in the course? So that is an excellent question, and actually a really tricky one to answer, which is why I'm going to hand that question over to Shafani.
Yeah, I had a feeling you were going to do that. So it actually,
so just for context, Shafani, do you want to introduce yourself as well?
Okay, so yeah, I'm Shafali. I'm the open house manager, so that's why I'm here now.
But also
I'm a third-year student.
Yeah, exactly.
Yeah, I'm a third-year student. I've just finished my second term of the third year, and we're going to start our placements in a couple of weeks. So what's the balance between design and engineering?
Yeah.
Well, it starts off, it's basically half-half throughout the course, because whatever engineering you learn, it's always in a design context. They definitely make sure that whatever we're learning is very grounded in real life scenarios. And even though it seems like there are more technical modules than design modules, it's only because the design modules tend to run throughout your year. So while you're learning a bunch of different technical skills like computing, electronics, mechanics, at the same time, you're always working on design projects to make sure that you're rounded in both aspects.
I think that's a really good answer. Yeah. So the course structure that I showed on the slides is a little bit misleading in that regard, because the design projects always go on sort of all throughout the process, because there's a kind of longer journey for any given learning objective. Whereas we'll do like a short, sharp course about computing, and it's one term, and then off you go to the next thing. Someone's which question? Irieta, we've got, what programming language do you use at design engineering? So the main language that we ask you to learn is Python, which is what we teach you from scratch in year one. However, we also teach you some JavaScript. We also expect you to be able to work with some MATLAB and some Wolfram language. The key thing is we don't want you to learn a language. We want you to learn how to code, which is a general way of thinking about problems. And so you don't need to have any of those skills when you arrive, but it would definitely be helpful to you if you spent just a few days having a play with some Python before you got here, as I think that would give you a boost in the right direction. Why is a 4-year course more beneficial than a 3-year course, Yuvan has asked. I think the answer to that is pretty straightforward. Avoiding the obvious answer of like, you get 1 more year to learn some things. You also get a master's of engineering rather than a bachelor of engineering. So you certainly appear significantly more qualified, but in particular, your master's project is the first time where you really get the freedom to really pursue your own passions whilst also making use, really putting the skills that you've learned into practice. So I think that 4th year is absolutely crucial for cementing the skills that we have tried to teach you. Apart from maths, what other what other A levels are required for application? We only require maths, but clearly some subjects are more relevant than others. So we are more interested in someone who's done, I don't know, further maths or DT or physics, perhaps, than geography or religious studies. But we're also interested in people who've done geography and religious studies. So follow the subjects that you're really passionate about and enjoying. And we absolutely appreciate that we want and benefit from a very diverse set of minds in our cohort. And so we do have students who've done unconventional engineering subjects, and we benefit from that. So, hello, I'm currently reading Design of Everyday Things by Don Norman. It's a classic. Are there any more books I can read or things I can do to help my application build up my skills? So yeah, it's a great question. If you haven't, for the others in the chat, the Design of Everyday Things is a real excellent starting point. There are, of course, a vast number of other books you can read. I would say in terms of your application, having read a book is not a strong piece of evidence. And so what I'd really be looking for is for you to have learned some skills, put those skills into practice, and maybe even enter those skills into a competitive environment. And so Shafali, would you be interested in recommending one of your favorite design or engineering books?
Hi, okay. Maybe not so much books, but I think the Netflix documentary series Abstract was really great.
Okay.
But as Sam was saying, like in terms of actually making your own projects, I think I'm biased just because I really enjoy it. But I do recommend like starting out with some Arduino projects, which are always really useful because you will learn how to use those in your Gizmo module, but it's super fun, super easy, and very accessible. You can buy components anywhere, and it's just a great way to learn how to program, and it'll give you like some evidence in your application that you could put.
Absolutely.
Yeah.
Greg has asked, hi, I have an offer for next year. What would happen if I miss my grade? So as I mentioned, we make about 170 offers, but we only expect about 90 students to meet those offers. So if you don't meet your grade, there's a significant chance, I'm afraid, that you won't be able to come and join us next year. A very small number of students might miss their grade by a very small amount, and we may consider making them an offer anyway, but that is not the usual scenario. Do you make 4 A-level offers? No, we don't make 4 A-level offers, although, of course, we are impressed when someone is doing 4 A-levels, but our offer would always be based on 3 of them. How much of the course is mathematics? Well, we have one mathematics course, which is 2 terms long in the first year. And then for all the rest of the course, the mathematics that you need to do that subject is delivered in that subject, which is slightly different from other more classical engineering degrees. But I think it probably does strike the right balance. I'm a very enthusiastic mathematician.
I can add on to that if you don't mind.
Yeah,
so like in mechanics, in electronics, so the math course in year 1 basically gives you the foundation that you will need for all of the like technical modules that you'll do in 2nd, 3rd, and 4th year. So modules like optimization, especially machine learning, all of them, even if you're not necessarily doing math in the same way where you have like calculations to do, but in order to actually understand those concepts, you have to understand the math behind them, and that's what the math module in year 1 really does for you.
That's the plan. Great. Is it a good idea to take further maths at A-level? Currently I'm in the course, but we haven't started it yet, and I'm unsure how well I can do in it. Well, 2 aspects there. One is get 3 really good grades rather than 4 not so good grades. But also, if you do think you can do well in further maths without compromising your other topics, then it is a particularly impressive topic to do. It is not always easy to compare whether one A-level is harder than another A-level, but obviously it's pretty clear that further maths is harder than maths, and that will stand you in a good stead. And I think the thing that I challenge a lot of students to is when they arrive, if they are strong mathematicians or perhaps strong in some of the technical subjects, really push yourself to focus on the design side and improve your design skills. And if you are particularly good at the design and creativity aspects, push yourself on the technical side to make sure that when you get to the 3rd and 4th year, you are reasonably well-rounded engineer. You mentioned joining some competitions for projects. Where can I find these contests? Well, there's a very wide range. There's not a sort of single place to look for these, but speak to your teachers at school who might be aware of some relevant to your sort of local area. Our website also has more information about some of the things that we are interested in. Could you share the list of electives? I don't have it to hand, but we do have information about that on our website as well. Our website is actually a pretty good place to look for all of this stuff. Ji Yang is asked, do you think that COVID will impact the way the course is taught in the year starting October? I'm amazed that this is the first COVID question, but it is quite possible. But the UK has been pretty good with its vaccine rollout, and I think it's quite likely that life will be significantly normalized by October. This year was all online, or that's not quite true. This year was the vast majority online, with some in-person activities, but there would always be in a particularly COVID-safe way. So 1/3 of the class spread out across a room, not as fun. And it has to be, we have to be honest about this, clearly not as fun as it might otherwise be. However, I think it worked reasonably well. I feel particularly sorry for this year's first year students, because obviously they had to spend a lot of time sitting at home when they would otherwise have been meeting lots of new friends. However, they're going to have a fantastic time next year when some of you arrive. So I think, it could have been much worse. And we at the school have quite a lot of experience in online teaching. And in fact, I've got a slide or two on that. This is our one of our professors, Peter Childs, who's the founder of the school. And he's delivered a course about creativity online. And I've also made a course online about the mathematics of machine learning. So there are quite a lot of expertise in online teaching in the department, and hopefully that means that we're doing a reasonably good job of coping with the current situation. Is it a good idea to take further? Oh, no, hold on. Could you, where have some of your recent alumni ended up working? So because we're only just starting up, we're in a slightly strange position of, we have now sent out requests to all of our alumni to ask if we are allowed to share where they have gone to work. So Shafali, you would be entitled to say, as friends of people, where they have gone to work, but I wouldn't be entitled to say.
I was just going to say that actually, if you're wondering what people have gone on to do after Desert, literally tomorrow we have another event where we have 5 of the alumni who are coming back. So I can tell you the companies that they work at. So we have Anna, who's working at Microsoft. We have Zach, who works at Dyson. Anna works at Google. Zach works at Dyson. And we have Gabrielle, who's working at Microsoft.
I thought Gabrielle was at Apple.
That was, I think, for his placement.
Okay.
Yeah. But now, after he's graduated, he's gone to Microsoft.
Not just the big tech companies. We've also got people who've gone to like small boutique design firms, educational foundations, a very wide range of places.
Yeah. So Josephine, she's working at, I think it's Possible Future. I think that's what it was called. Yeah. And we have Ben, who's working at Cytera Cellworks. So these are smaller companies, and that's why we got like a mix of people, so they can give you their different experiences working in a bigger and smaller company.
Superb.
But yeah.
We've got a question here. Do you accept A levels which are taken a year early as already met grades? Yes, we do. Also, is there any way for us to ask more questions in the future after this webinar? Yeah, just email design.engineering@imperial.ac.uk. You can find that email address, of course, on our website as well. We are pretty easy to Google. So any other questions for us today? It's been great having so many questions. It's almost as if you've asked one each. Well done. Is work experience a good idea for applications? Sure is. Yeah, that's the kind of thing we'd be delighted to see. It's a real sort of piece of evidence that you've gone off into the world, made the effort to go and develop your skills and push yourself. How close is the design aspect of DT to the projects and courses that you offer? Reasonably close, in terms of, obviously A levels are somewhat constrained in what you are able to do, but yeah, there's a lot of conceptual overlap between some of the DT syllabuses and some of the things that you'll do here in design engineering. So it's certainly a worthwhile topic to study. What extracurricular activities do you offer? Well, that is a huge question. I think Imperial has possibly got the most student societies of any university in the UK, or it's got some kind of crown like that. There's a huge amount of clubs and societies that you can take part in, whether that's sports or crafts or like social enterprise type activities. Shafali, any that you're involved in that you'd like to mention?
Yeah, I feel like you might have a harder time finding a society that doesn't exist than you do finding one that does exist.
Yeah.
There's literally societies for everything. Like you have the normal sports ones like football, you have martial arts, and like martial arts as in there's a different society for each one. There's taekwondo, there's Muay Thai, there's boxing. There's also like smaller ones, like there's knitting society, there's a magic society, there's societies for each country. There's like
Each
language
type of music.
societies.
Yeah,
I can't, if I went on, I would speak for the remaining time, but basically anything you want to do, you probably will be able to.
Yeah, and you must do it. You must get involved.
Yeah.
It's a great time to go, and great opportunity to meet new people from different courses and learn cool new skills. It's often heavily subsidized as well. So I think if you go and do like scuba diving, it will be the cheapest way you could ever learn to scuba dive in your life.
Yeah.
I'm currently taking product design. Is it a good idea to tailor my coursework project somehow to the course? Yes and no. I mean, a product design course will allow you to show a lot of the skills that you're currently doing. In the interview, we will give you some time towards the end to show off a portfolio of work, which means a very few images, or you can share your screen and show a video or whatever, but show off a small amount of the work that you've done to give us a feel for just how impressive your skills are. How much room for creativity is there in the course? I can just say, I think a lot, but more so in your fourth year than your first year. So, in the early years, we are trying to get you to learn some quite particular skills. And as the years go on, we allow you more and more freedom in what you can do. Where does business come into the course? Well, again, actually, business comes in towards the end of the course, not only in terms of the electives, but also some of our core activities like enterprise rollout, where we study how companies actually work and how you turn an idea into a product. I have an offer, but I'm thinking of taking a year out to do a year in industry and work in engineering. Would it be possible for me to reapply in a year's time? Would this negatively affect my application? Reapplying is absolutely fine. It wouldn't negatively affect your application, especially if what you did in this year was relevant to the degree. Is robotics an essential on the course? Yes, it is an essential on the course, in part because it ties together so many other skills that you have learned, and in part because we feel it's going to be such a central aspect to the future of engineering. Any other questions before we call it a day so we can all go out and play in the sun? Okay, well, thank you all so much for your attention. I hope you found that helpful. And please do get in touch through our email address, design.engineering@imperial.ac.uk. What preparations are ideal for the interview? Well, I mean, practice having an interview may sound like an obvious thing, but practice sitting down with someone and have them ask you about why you want to study the course. Why do you think this course in particular is a good course for you? We're going to ask you a little bit about maths, about design, about technical ideas. We're going to ask you to show off some of the previous things you've got up to, some of your previous work. So fairly standard interview setup. So please, take the time to get familiar with that. What work experience helps? Things that you think might be relevant to the course. Do you need to do any super curricular activities? What would you recommend? Anything that you think might be relevant to the course, or particularly show off your passions? And Shafali, what time is the talk tomorrow for the alumni, and how can people join it?
Okay, do you want me to talk about the alumni talk and then you can answer the rest of the questions?
Yeah,
so that's at 1 p.m. tomorrow. On the Eventbrite page that you got the tickets for this talk, you can also get tickets for that one. It's all free once again. It's going to be the same. It's just going to be like this. It's a Zoom webinar, and that's not really a talk. It's more of a panel session. So actually you, the audience, are going to be much more involved. We'll just have our 5 guests and they'll each give a short introduction, and the whole thing will just be you asking questions about what they're doing and how they think that Deseng kind of plays into that. But yes, please join us tomorrow. It'll be a good event.
Excellent. Well, I hope many of you can. Okay, well, thank you so much, Shafali, for organizing this. Thank you again to all of our guests today for asking such thoughtful questions. And I hope to receive your applications in future. Okay.
Yeah, thank you very much, Sam, for the great talk.
My
I just
pleasure.
wanted to let everyone know that the open house website will be live today afternoon, so you'll be able to actually see projects from across all the years and even the GID and IDE master's programs on the site.
Awesome.
And you'll also be able to watch like the recorded version of this talk and have access to the events in the coming days from the
Fantastic.
site.
Okay,
Yeah.
take care, everyone. Goodbye.
Thank you. Bye.